Hi, everyone. My name is Himanshu Dwivedi from Data Theorem Incorporated. And today I will be talking about how hackers hack your APIs in 15 minutes or less. And that key part is 15 minutes. So we're going to dive deep into that. Let's get started. All right. So let's first focus on the important part of the title, which is why 15 minutes. And the first bullet point is because hackers like to hack, security research like to research. And let me focus what I mean by that. So when you talk about hacking, hackers have creative interest. It's not always for academic reasons. So they will hack for fame to be popular with their friends. Their friends might be 12 years old or might be 44 years old. They like to do chaos. They like to mess with people. They like to F with people. They want to make sure they disrupt your lifestyle just for fun. So they're not the most balanced people in the world. And sometimes it's entertaining just for themselves and their community to hack. And obviously, financially, over the last 20 years, financially, there's a lot of incentive. That's not the sole driver, but it could be a secondary or primary driver, but it's not the sole driver as many people think. Now, conversely, researchers, there's a lot of security research out there. They do it for intellectual stimulation. So this person here is Dan Bonet. He's on our board for Data Theorem. He's the computer science leader at Stanford University. Him and his students do security research for academic reasons to make the world a safer place. But while their tactics might be very similar, if not the same, the actual reason for it are very different. And it's a difference between hackers and researchers. And so my bias, my background when I was much younger was from the hacking community. That's where I started. And I was doing plenty of immature and silly things. The reason why I put this is that my bias is hackers do cross that evil line. They will do things that they're not supposed to do. Hopefully it's harmless. Hopefully it's like as simple as graffiti, but sometimes it can be more. But the mentality of a hacker is not normal, nor is it something you can plan for. So the chaos part of hacking is a very important part of the presentation. Okay, so here's an example of researchers. So researchers from a lot of upstanding universities researched or published a paper a few years ago of how this stop sign, if you look at this stop sign, how two black stickers and two white stickers could actually poison machine learning. So automated vehicles would not be able to know this is a stop sign anymore. So for you and I and people who are used to seeing this, we can clearly see this is still a stop sign, even though there's stickers on it. But machine learning vehicles were tricked to basically hide this from being a stop sign. They poisoned the machine learning. So this did not appear as a stop sign to many automated vehicles. So it's a pretty brilliant attack. A lot of research, a lot of talent to go into this. And it's pretty awesome from these universities. Now, here's what hackers would do for that very same attack. If you live in California, there's a highway called 101, kind of connects Northern California to Southern California. And so here's an example. If someone asked me to do that, I wasn't as honored as others to go to Stanford or great universities like that. But as an ex-hacker, what I would do is go stand on 101 with a stop sign. So if you see this, if you see here an automated vehicle, a Tesla, but it could be any automated vehicle that is doing, self-driving, and they see a stop sign on 101, what are they going to do? They're going to stop, right? That's what they're supposed to do. That's, to my knowledge, what they're going to do, right? So this is what hackers do. They want to mess with people. You could be saying, why would they do this? Why would they want to do this? That's not the right question they're asked. That question is, can they do it? And if they can do it to mess with people, they probably will. So then you can argue, well, like, wait. Cars will know that it's on a highway at 55 miles per hour, and that's not where a stop sign should be. so the car will know to ignore me on 101. And that might be true, but is it? Because what if there's construction on that? Construction is just random sometimes. Sometimes it's planned. If you live in the Midwest, there's 2 seasons, winter and construction. In other parts of the country, it's pretty random. So what if there's a construction worker, as you see here, holding a stop sign for some patchwork that was unplanned that day? That Tesla needs to be able to stop. So what's the difference between needing to be able to stop here because a hacker is trying to create chaos versus a legitimate construction worker for the exact same situation, right? It's a very difficult problem to solve, and that's why hackers know that, and they prey on that. They prey on usual, typical activity that you cannot stop, and they try to abuse that for their own advantage. All right, so what does that have to do with APIs? Well, there was a hacker group a couple years ago that was exploiting this action that was successful over 35 times. And I'm just going to show you multiple examples of that. So this hacker group essentially on March 12th was started reverse engineering all these mobile apps. And when they found a random mobile app, they would find APIs embedded in mobile apps, which is honestly very normal. And they would connect to such APIs pretty easily. It's just like essentially connecting to an open system, and they would find data. And so they just kept on doing that over and over and over again. So here's an app called 63 Red Safe that essentially had open admin access. Here's another one called Get You that has a search API operations. These are all headlines from the public apps that were done. Here's a third one called Plenty of Fish. This had an API response operation open. And this one is called Smart Tubs, called with an admin API open. So the list goes on and on. So as you hear from security vendors like Data Theorem and like us, you're going to hear about this attack called BOLA, Broken Object Level Authorization Attack. It's an OWASP top 10 issue. And I'm here to tell you, BOLA is important, but all the data breaches are not BOLA. They're simple open APIs out there on the internet being identified by hackers and compromising large amounts of data. And here's an article in 2021, which basically confirms that 2/3 of data breaches are just APIs lacking authentication. It's not some fancy BOLA attack. It's not some encryption bypass attack. There's just open APIs out there that people are connecting to. So how are they doing this? How are they making it look so easy? Well, let me show you that. So the first thing they do is they go to a random app in the App and Play Store. They download that app, just like you and I would do on our iPhones or Android phones. But what they will do is decrypt the app. And so let me kind of show you that process. I have a video here. So I have nothing against Amazon. I just chose a random popular app. They're good people over there, over at Amazon. I know many of them. So, but here's us, and don't worry about the small font, but here's us downloading the Amazon app on our iPad on the right side of the video. And on the left side of the video, we're just decrypting it. And why I'm showing you this is a very simple task. Decrypting an iOS or Android app is not a huge security bar. It's fairly easy. So here is just a quick way to decrypt that data. And so now we're seeing all the source code from the app, all the APIs from the app, which is just normal. There's nothing wrong with this at all. Like, this is just simple stuff. So that's the first step they do in the attack. And there's a screenshot there. So the next thing they do are they're going to find the APIs. So let me kind of show you that video. So in this video, now we're hunting for APIs from that decrypted app. We have a tool called API Hunter that automates this for us. So we're running it now on the top of the screen, and we're pointing it at the decrypted Amazon app. So now the APIs, you'll see it in the green highlight. These are all APIs found in the Android app. Very simple stuff. So far, nothing sophisticated happening here. Now, here's the clever part. This is where I'm going to give the hackers a lot of credit. What they did is they essentially sat on the data from one release, And then when the new release of the app that they were targeting was out there, they did a diff. So essentially what they wanted to do is make sure that they looked for something called shadow API. So let me show you that video. So now they have two versions of the app, the old version and the new version. They decrypt both of them and have APIs for both of them. Now what they're doing is doing a diff, and they are essentially saying, show me the new APIs. Forget about the ones that were there in version, let's say 10. Show me the APIs that showed up in version 10.1. And that's what you'll see here in the blue font. And why this is clever is they targeted only the blue APIs, the brand new APIs. And the reason why they only targeted the blue or brand new APIs is they knew most organizations probably don't even know that happened, because the developers write code. Mobile developers have this kind of green light to do whatever they want, whenever they want. The chances are that the security team has seen these new APIs is very low. And because that's very low, the attack probability is very high, or the success probability of attacking it is very high, because the security team hasn't seen it. Unlike the other APIs that have already been registered and known by the security team, those are probably something that have already some level of security review. So why even bother with your time? If you have 15 minutes, why take those precious 15 minutes to look at APIs that a security team has already reviewed versus, hey, show me the APIs that are brand new. More than likely, the security team doesn't even know they exist. And if the security team doesn't know that they exist, the chances are they might not have authentication. And that's what they did. So now here's a video of us essentially connecting to all the APIs we found. And you can see everything in green was a successful connect. Everything in red was unsuccessful. So it's not like everything was successful, but notice how many successful connection attempts we made to these brand new APIs. And then the final step, which is the data breach step, is extract the data. So here's a video of us essentially. Now, this is not the Amazon app. This is where it's all test data. Everything else was a real app. This is where it's all our test data. But this is what the hackers were able to do in those 5 examples I showed earlier in the presentation. You can see here, we have test data with social security number, password hash, first name, last name. This is all the stuff that was available just by connecting to the API. And the API was a shadow API, a new API, an unregistered API, because it was brand new on this release, not on previous releases. And that's the clever part of being a hacker. Like, they are efficient. They don't want to waste their time. They want to get in and get out. And they want to test all your web APIs, your mobile APIs, so on and so forth. So what did they do? They decrypted your mobile app. They hunted for APIs, but then they did the diff. That's the 15 minutes part. They did the diff. And then when they found the net new APIs, they connected to each one of them. They extracted all the data, and the ones that had data that was useful, as you see here in the screen, they essentially performed a data breach. All in 15 minutes, all automated, all scripted, without almost any human effort. And what can they target? Obviously, I'm showing an example with mobile apps, but they can target web apps, serverless apps, or just any API out there, B2B API. So the attack surface is humongous. And the fact that they can script it and just look for net new APIs is a clever way to pull off a data breach. So yeah, so what are the tools that we use to kind of pull this off? This is API Hunter, and another one is called Shadow API. So if you are interested and you're a researcher, hopefully not a hacker, reach out to us and we can give you access to these tools. And some bonus coverage. So we have about 5 minutes left. The same thing applies to your cloud, not just API. So I won't go through this as much detail, but here's some mobile apps also being compromised, but not by APIs, by cloud resources embedded in their API or embedded in their mobile apps. This particular one was an Elasticsearch database. This is Alibaba Cloud Storage on KidsGuard, and this was also AWS Cloud Storage. So the idea is the same on cloud as it is on API, that you decrypt, you get, in this particular example, instead of finding open APIs, you're finding keys and tokens. So here's an example of finding a key. And this is an app. This is a test app where we found 3 keys. The first one is a password, obviously very not ideal, but compromising a single password is not that big of a deal in terms of data breach. Let me repeat that. Not a big deal in terms of a data breach because it's a single user. Sad reality, but true. The second thing is the bigger part. The second thing is a data breach because this is an API token inside a mobile app that has access to cloud storage, that has access to millions of data. This is a data breach. This is what's happening on those other examples. So it's not just your APIs being hacked in 15 minutes, it's your cloud being hacked in 15 minutes as well. So the solution here, to end on a positive note, is detect your shadow APIs, your unregistered your APIs, your net new APIs. Have a process to determine every new API created on every new release and make sure it's visible and make sure it's tested. But realize mobile teams or even serverless teams, they have a lot of leeway to publish APIs. If you're not aware of them, then they might not be authenticated. If they're not authenticated and they have access to sensitive data, you have a data breach on your hand with a very low-tech attack, which is item number 2. Make sure all authenticated APIs are reviewed. Having unauthenticated APIs is not a bad thing. You just need to confirm there is no sensitive data on these unauthenticated APIs, and you need to confirm that every day because you never know what's going to happen one day to the next. Number 3, make sure you're looking for keys and tokens in your mobile and web apps. Scan those mobile and web apps, not only for security, but also to make sure any embedded key and token is not sensitive. And obviously, I'll analyze your cloud daily for PII. And that's about it. Thank you for your time. If you have any questions or if you want to have a copy of the tool, feel free to email me or my coworker who helped me with this presentation. At this point, Data Theorem thanks you for your time and have a good rest of your day. Bye, everyone.